Okay, so now 7.2 deals with simple machines. The whole purpose of simple machines that are things that we see in everyday life is to make the tasks, the work that we need to do easier. The uh, the purpose, the whole purpose of having and using those simple machines is to make the task, the work that we need to be doing as easy as possible. Okay, so they have one movement. So they have simple machines, then when they are combined, of course, that they have more. But those are mechanisms which will be if you go to engineering and you will study them. So the very first type of simple machine are ramps. You see ramps on every every everywhere actually. Okay, so now ramps increase distance to decrease work or spend uh, or to spend less energy as the object is moving. So an example of a ramp will be if we have stairs here. So let's suppose that we have those stairs. Sorry. Now, if you are going from point A to point B, here at the top of the stairs, then what you will see is that a lot of work that it's needed to be done. It is a lot of work that you need to be doing. However, what do we do instead of taking the stairs like this? What do we do is we add a ramp here from point A uh, to point B. And then what it is doing, the ramp is increasing the distance. However, it is making the work that we need to be doing less. So the energy that we spend is way less if we are using a ramp than if we are using the stairs. This is the first type of simple machine that we see. The second one is lever. So what they are doing is they are allowing us to lift heavy objects using less energy and doing less work, because as we said on 7.1, energy and work are the same. So when you are using less energy, then you are doing less work. So they go hand by hand. Whatever you are doing more, then it is more, and whatever you are doing less, it is less. If you are doing more energy, then you are doing more work. If you are using less energy, then you are doing less work. Levers are bars like pivot on fulcrum to move a load with less efforts. Okay, now when we are talking about levers, then we have three classes. So the first class lever is the, I will just schematically draw it, and you can check more in your textbook for better pictures or so. So what it is that I will draw it like this. So here you will have fulcrum, oh, fulcrum, and in one side you will have the load, and the other side you will have the effort that you are putting. When it is in equilibrium, you don't need to do anything. However, when you need to lift, let's suppose that the fulcrum is still in the middle. Oops. Excuse me. So let's say that fulcrum, you have a fulcrum here, and then you have the load here. then what you are doing is you are putting an effort here to lift this load up. Okay, so the situation in which it goes E for effort, F in the middle, and the load at the very end is known as the first class lever. Okay, so the examples of first class lever are crowbars, pliers, scissors. They are all examples of first class lever that we use on everyday. Even in our everyday, in our home, we can see and use them. Okay, so the configuration of the first class lever is EFL, meaning that effort is applied on fulcrum, which is a point that doesn't move, and load that is either lifted up or it's moving. Okay, the second class lever, second class lever is a lever that in one end of the bar, it's the fulcrum is in one end of the bar, and the load and effort are on the other one. So a can opener is, let's say, a second type of class lever. So if you have a situation in which fulcrum is here, and then you have the load is somewhere in here, and the effort is here. So if for the first class lever, the configuration is EFL, for the second one is ELF. A wheelbarrow, a can opener is the example of the second class lever. The third class lever is very similar to the second, so third class lever is very similar to the second class lever in the sense that it is the fulcrum is at the very end, but now what do you have is that the effort in the third class lever is between the load and the fulcrum. So as the example of the what do we do every day, like how do we see the third class lever in our everyday, as axes, tennis rocks, hockey sticks, and things like that. The configuration of it is something like this. So here is the fulcrum, and the load now is here, and the effort is here, is between the load and the fulcrum. So it is like LEF is the acronym that is used for the third class lever. So sometimes it seems so that those class levers are confusing and are difficult, but just to remember something about for the first class lever is EFL, for the second class lever is ELF, and for the third class lever is ELF. So when you are asked to to define what class lever is this or that situation, then what do you have to do is you have to just remember those three things, considering that E is the same as effort, uh, L is load. Effort means that where you are putting the force, what are you, in which point you are pushing or pulling. Load is where the work that needs to be done is placed. And F is fulcrum, which is the point that doesn't move. So when you see it's not moving, even on this, it's not moving, it's supported and it is not moving. Here is supported, the ramp is supported and it is not moving. And here it is supported and it is not moving. Okay, next thing that we will see in terms of the simple machines is that is known as the distance multiplier. A distance multiplier moves a load, weight, through a large distance, but require a short effort. Okay, a fishing rod is an example of a distance multiplier. Okay, so when we have a distance that you need to go in when you have to move a load in a long distance, then what do is you use something that it's putting a less effort to move the object in this long distance. The word is saying it, distance multiplier, which means that less effort, because that is the whole purpose of the equipment that we are using, to do less work and to do less effort, but to realize to make the object move for a long distance, higher speed, and things like that. And the next one, beside ramp, simple machines, which are in three classes, and distance multiplier, is that is known as the force multiplier. So again, the force multiplier is a simple machine that easily moves a large load. Okay, a small force is applied to move a large load. So let's suppose that your car is stuck in the snow, let's suppose. And then what do is, with a small force that you are pushing it, you are making the car to, which is a huge load, to move. So the force that you are applying is multiplied, and then the load is moving. Okay, so those are things that you will see in terms of the simple machines. Ramp, okay, levers that are in three classes, distance multiplier and force multiplier. Ramp is when you are making you are elongating the distance, so that the work that you are doing is less. Lever is to, or levers are to make a load to move, and then there are three classes of first, second, and third. Distance multiplier when you are moving with less effort a long distance, and force multiplier when with a small force you are moving, doing work in a heavy object. That's it for 7.1.